Hello guys, today we will see the Leetcode problem number 3650, which is minimum cost path with the age reversals. So in this question you are given the directed weighted graphs, which is from 0 to n minus of 1 ages are there, nodes are there, and an array ages of I. So in that ages of I, u and v means source to destination, and with the weight wi is given. And after that, in this paragraph it is given that the overall conclusion for this paragraph, it says that we can reverse any of the age, and for reversing that age we will need the cost 2 into wi. Means after reversing that age, the cost for the u to v, means initially the u is source and v is destination, and after reversing that v is source and u is destination, and their cost will be 2 into wi. Okay, the cost will be 2 into wi. So now we have to minimize the total cost to travel from 0 to n minus of 1, means from 0 to n minus of 1 means 3. Okay, 0 to 3 we have to travel. Okay, so here when we traverse from 0 to 3, 0 to 1 by using the cost 1, and after that we do not have any of the way to travel to third node. Okay, so we can reverse this age, and after reversing that age, the updated cost will be 2, just like this. Okay, so in this case, when we I will just rough this. Okay, so when we have now, when we inverse this node, so our cost or the updated cost will be 2 into this cost. So that's why the updated cost will be 2. Okay, after that we can reverse this age also, and our updated cost will be 6. This age we can reverse and the updated cost will be 4. This age we can reverse, the updated cost will be 8. So we can go from this to this. Okay, so this can be our source to destination path. This can be one of the path. Here we can get the 6 as our cost, and here we can get 3 and 2 means 5 as our cost. Okay, so in this way we will traverse it. Now if we talk about the solution, so in the solution we are storing all the paths. Okay, whether it is a directed path or inverse path. Okay, so this is the path which is given to us, and then we have inverse that, so we have reversed that particular age, and after reversing that age we are storing it v to u. Okay, so we are inversing, means we are reversing that age. Okay, and the updated cost will be 2 into w. Okay, so this is our twice of weight. Okay, after that we will apply the Dijkstra to get the shortest path, to get the shortest cost to reach to that destination. Okay, so this applies the single source shortest path algorithm. Okay, and let's see what we are doing in our Dijkstra function. So in Dijkstra function, if you know the Dijkstra algorithm how it works, so we are taking the visited node. If they are visited, so we will not visit it again. Okay, then the distance is there, which is storing the initial distance, which is infinite for all the nodes. And after that, now priority queue is storing. So priority queue is working on the principle of distance and vertex. So it will the priority queue, at the top of the priority queue, only the minimum distance will be present. Okay, so this vector of pair of int and int greater pair of int, this represent that mean heap. Okay, we by using mean heap, so at the top of the priority queue, the vertex with the minimum distance will be present, and the minimum will be sorted on the basis of the distance. Okay, so distance will be minimum, then only it will be taken. So in this way we are prioritizing the edges, we are prioritizing the paths which are having the minimum distance. Okay, then in the our priority queue we just push our first, means the zeroth source. Okay, and after that we have pushed it, into our priority queue. So the distance will be distance for that source will be 0. Okay, because the distance for that source, particular source, means the distance of 0 from 0 will be 0. Yes, okay, means the node, okay, for that particular node will be 0. After that we will traverse it until our priority queue gets empty. Then after that we are taking the topmost pair which is present. Okay, the topmost pair which is present will be represent the minimum path having the minimum distance, the path which is having the minimum distance, and the vertex. Okay, the vertex up to which we have the minimum distance. Okay, and on that minimum distance, by using that minimum distance we will traverse all the possible nodes. Okay, and after that traversing that all the possible nodes, if now 3 to 4, okay, we are traversing and we have only the 5 as a cost. Okay, and now from 3 to 6, okay, we are traversing, and from there we have 1 cost. Okay, 1 as a cost. Okay, now here we have already traversed from 3 to, okay, so from 3 to 6 we have already visited the 6 and already marked the 6 as a as the distance will be 1. Okay, the distance for the 6 will be 1, the minimum distance. Okay, and from 3 to 4 it will be 5. Okay, 5 as the minimum distance. And after that now when we traverse try to traverse the fourth one. Okay, when we try to traverse the fourth one, so it will be marked as 2. Okay, sorry, 5 plus 1 which is 6, but the 6 is not because 1 is less than 6. Okay, 1 is less than 6, so that's why it will only 1. Okay, so that in this way the distance from the source will be our this, and destination will be all the nodes. Okay, this can be destination, this can be destination, any of the node, all the nodes can be the destination. Okay, but the source will be only 1. That's why the Dijkstra is said as the single source shortest path algorithm. Okay, and in this way our cost for all the nodes will be calculated and it will be stored in our distance array. Okay, and every time when we are present at any of the node, so it's all the childs. Okay, all the childs will be visited now. Okay, in this for loop. Okay, during this for loop all the childs will be taken and they will be visited. Okay, after there, okay, the child of vertex v, and this will be the weight for that particular age. Okay, then we will take that if that weight, the distance plus weight is less than the already present distance, so then we will update that distance and we will push back that particular distance if it is less than that, but already having distance. Okay, and after this, after applying a whole for while loop until which the priority queue gets empty, and after getting all the while loop gets completed, so we will have the distance array filled with all the distances, all the distance from the source to destination. And in this way if now it can be taken that it can be possible that the distance from source to destination, it is not possible. Okay, if there are no possible edges which are present from source to destination. Okay, so it can also be possible, means if we have 1 to 2 edge but 3 node is having okay, so 4 and 3 is just like this, there are edges present. We can start from, okay, 0 0, we have to start from 0 0 to 1, okay, and 3 to 4, okay. We have to reach from 0 to 4, but there is no such pair which is present, no such path is present from 0 to 4. So that's why here in this one, so it is given from 0 to 4, the distance will be infinite, okay, the distance will be infinite. So that's why if we have to take out this condition, if the distance nodes of I minus of 1 is equal to infinite, so we have to return -1, which is mentioned in our question also, okay, because if it is not possible, then return -1, okay. So that's is our answer. And if you have any doubts, please comment down below, and I will see you in the next video. Thank you.